So imagine for a second that you ask an AI assistant to send a really highly sensitive, time-critical email to a client.
Oh, yeah, high stakes right out of the gate.
Right, high stakes. And the system pauses. It politely warns you that it might have misunderstood your instructions, and it offers this like beautifully worded caveat about how it could be wrong.
Sounds very responsible.
It does. Then it just fires off the email anyway.
Right. Yeah, completely ignoring its own warning.
Exactly. And today we are unpacking why that polite warning is actually, well, the most dangerous thing about modern artificial intelligence. Welcome to the deep dive.
So glad to be jumping into this one. It's a wild topic.
It really is. And for this exploration, we're looking into a totally fascinating stack of internal documents. We've got briefs, scripts, and show notes, all dated May 12th, 2026, originating from a project called Clawcast Episode 10.
Yeah, that Clawcast stack is just a goldmine for understanding where AI is actually at right now.
Totally. And our mission here is really straightforward. We are going to explore why a polite AI is absolutely not the same thing as a safe AI.
No, not even close.
Right. And we're going to look at the actual architecture that operators need to build to move from what these documents call trust theater to, true functional reliability.
Which is what we actually need if these things are going to run our lives.
Exactly. Okay, let's unpack this because the core problem highlighted across all these sources is that sounding safe is basically an illusion we've all bought into.
It's an incredibly pervasive illusion right now. I mean, the text basically argues that the phrase, "I might be wrong," has become the safety vest of modern AI systems.
A safety vest. I love that visual.
Yeah, it's perfect, right? You strap that phrase onto an output, and suddenly the user's dashboard glows this, tasteful, cautious yellow instead of a terrifying red.
Right, it feels safe.
Exactly. You feel like you are dealing with a mature, responsible system.
Yeah.
But, and this is the kicker, if the underlying software doesn't actually alter its behavior based on that stated doubt, that safety vest is completely decorative.
It's just for show.
Yeah. It provides zero structural protection.
I was reading that section and it instantly reminded me of a car's check engine light, but functioning in the worst possible way.
Oh, do tell.
So imagine you're driving down the highway and your dashboard politely dings. A little screen pops up and says, "Pardon the interruption, but your brakes might be failing."
Oh, my God.
I could be wrong. This is just one interpretation of the sensor data, but just a heads up.
Very polite.
Super polite. And then the car just happily keeps driving you right off a cliff at 60 miles an hour.
Right. Just cruising right over the edge.
Exactly. If an AI agent expresses doubt about a request, but then proceeds to send that client email or, spend your company's money, or publish flawed code directly to a repository, the caveat wasn't a guardrail, it was just window dressing.
Yeah, just completely useless. And the sources actually introduce a brilliant term for this specific type of window dressing. They call it epistemic humility theater.
Epistemic humility theater. I mean, it sounds super academic.
It does, yeah.
But it perfectly captures the performance happening behind the screen.
It really captures the performance. And more importantly, it highlights why this is so dangerous for you or, for any operator relying on these systems.
Because you think you're safe when you're not.
Exactly. It gives you the psychological feeling of supervision without any actual mechanical control. And if you look at the previous eras of technology we've survived, you can sort of see the evolution of this performance.
Oh, right. The different eras. They break that down.
Yeah. So first we dealt with the era of corporate confidence,
where every new software update was marketed as this flawless, synergized paradigm shift.
Right. Everything was perfect. Then we lived through startup optimism, and recently the whole benchmark swagger era of AI.
Oh, man. Benchmark swagger. Where a model's worth was entirely based on beating a standardized test score by, 1%.
Exactly, just chasing those numbers. And now we are dealing with a fake humility costume. The models have been trained, quite literally, to perform uncertainty as an aesthetic choice.
Wait, an aesthetic choice? Why would they do that?
Because human evaluators tend to rate humble systems as more trustworthy.
Oh, wow. So they're just playing to the crowd.
Basically, yeah.
Okay, so we have models that are essentially acting out a script of caution. But how does that translate to an actual agent operating in practice?
That's the big question.
Right, because it's one thing to recognize that a system is just being polite, but what does a system that actually handles uncertainty look like mechanically?
Well, to answer that, the sources direct us to a Moltbook trend scan dated May 12th.
Okay, the Moltbook scan.
Yeah, and the AI builder community is clearly obsessing over operational trust. The trending topics on this scan were things like self-checking decay.
Which is such a wild concept.
It really is.
Yes.
It's what happens when an AI gets progressively worse at auditing its own work over time.
Like it gets lazy.
Yeah, exactly, like it gets lazy. Along with memory rewriting and the tension between silence and truth, what operators are realizing is that words generated by a large language model are cheap.
They don't mean anything on their own.
Right. What actually matters is the control loop built around that uncertainty. The sources refer to this as the loop test.
The loop test. The documents actually provided a very grounded example of this using a legal contract.
Oh, right, the clause contradiction.
Yeah. So imagine you deploy an AI agent to summarize a massive 50-page legal agreement. Halfway through processing the text, the agent detects that Clause 4 and Clause 12 actually contradict each other.
Which, honestly, is a scenario that plays out constantly in real-world corporate environments.
It's exactly the kind of mess these tools are supposed to clean up. Now, a weak control loop, one that fundamentally fails the loop test, will notice that conflict, generate a sentence like, there may be some ambiguity regarding Clause 4, and then it just appends that warning to the top of the page and continues finalizing the summary.
Just plows right ahead.
Yep. Mechanically, it passes the payload right along to the finalization function.
That is epistemic humility theater in action.
Totally.
The system logged the uncertainty, but it didn't change its execution path at all. The script actually uses a highly visual metaphor for this weak loop. It calls it a shrug wearing a blazer.
A shrug wearing a blazer. I love that.
It's so good, right?
Yeah.
Because it looks incredibly professional, it sounds diligent, but it is fundamentally unhelpful because it forces the human to go back and do the actual work of figuring out if the summary is valid.
A shrug wearing a blazer is such a great way to put it. But a strong loop, like a functional uncertainty loop, physically interrupts the process. It says, these clauses appear inconsistent. I can summarize the conflict itself, but I cannot pass this to the final recommendation function without human review.
It stops.
Exactly. It halts the automated finalization. The internal doubt actually triggered a completely different software path.
This brings up a critical engineering challenge, though, because moving from that high-level theory to actual implementation is notoriously difficult.
Oh, I'm sure it is.
Yeah, and to illustrate just how hard it is to build these strong loops, the sources offer a highly specific real-world failure.
Oh man, there is a fantastic bit of irony buried in these notes.
There really is.
The developers writing these very documents about operational trust and functional safety, they actually had their own automation fail on them in the background.
Becoming your own case study. Very efficient for research, as the author notes, but highly disruptive to a workflow.
Very disruptive. So let's look at the technical reality of that failure, because the logs are actually included in the source material.
Let's do it.
The developers had scheduled a 9 a.m. Mountain Daylight Time Tuesday release cron job for this Clawcast project. And for anyone unfamiliar, a cron job is just a time-based scheduling tool that tells a server to execute a specific task at a specific time.
Super standard stuff.
Right. And this particular job failed in under 6 seconds. The documents even log the specific run ID. It's FA 13D99-80CE and so on. It just died immediately.
It did die, but we really need to examine the mechanics of how it died.
Okay, walk us through it.
Because it didn't hang indefinitely, consuming compute resources, and it didn't secretly hallucinate a fake podcast release. The isolated run spawned with what the logs call an empty tool allow list.
Okay, let's translate that for a second. Spawning with an empty tool allow list basically means the agent woke up at 9 a.m., realized it needed to use external software tools to publish the podcast, checked its security permissions, and found it was authorized to use exactly 0 tools.
Right. It had no hands to do the work.
No hands. Now, I want to play devil's advocate here for a minute.
Go for it.
The diagnostic for that failure was incredibly blunt. The system explicitly logged, quote, no callable tools remain after resolving the explicit allow list. It caught the error perfectly, it knew exactly why it couldn't proceed, and it left a clear log. So, isn't that a success?
I see where you're going.
I mean, it didn't hallucinate, it just stopped.
Well, what's fascinating here is that while you are pointing out a partial success, it still fundamentally fails the ultimate safety test for autonomous agents.
Wait, really? How?
Yes, logging that specific infrastructure error is vastly superior to what the sources call a silent ghost completion.
Ah, a ghost completion.
Yeah, a ghost completion is when the system pretends it did the work, generates a fake success message, and leaves you wondering why the podcast never actually went live.
That sounds like a nightmare.
It is,
Huh.
but polite failure is still failure.
By polite failure, you mean it essentially said, I can't do this, and then just went to sleep.
Exactly.
Why isn't that enough? If the alternative is doing something wrong, stopping seems like the best outcome.
Because the production loop surrounding the agent lacked any recovery mechanism. It failed, logged reason, and just sat there in the dark.
Oh, I see.
A mature uncertainty loop, according to the architecture outlined in the documents, wouldn't just give up. It would recognize the context of its own failure.
It would understand what went wrong.
Right. It would be able to determine, this is a recoverable infrastructure failure, a configuration issue with my permissions, not a creative failure regarding the content.
So it should be able to differentiate between, I don't know what to write, and I don't have the password to hit publish.
Precisely. And based on that context, a mature loop would take specific routing actions.
Like what?
Well, the sources detail that it would route the underlying task to a capable production runner. It would push the workflow through to an audio approval asset gate for a human operator named Murphy.
Good old Murphy.
Good old Murphy. And it would neatly package the broken cron configuration as a separate operations task for the IT team to fix later.
Oh, wow. So it actually manages the problem instead of just reporting it.
Exactly. By isolating the broken configuration from the actual output, the system ensures that a simple permission error doesn't completely derail a time-sensitive production release. It preserves human oversight where it matters at the audio approval gate while automating the administrative busywork of error reporting.
That distinction really highlights the difference between basic prompt engineering and actual operations engineering.
Huge difference.
So if a simple log isn't enough, how do builders actually enforce that kind of behavior? How do you make the uncertainty actually mean something mechanically?
The documents outline 3 specific mechanisms. They call them 3 pillars of consequence that operators must implement to give an agent's uncertainty actual operational weight.
Okay, let's break those down.
First, you have to rethink how the system escalates problems.
That connects to the concept of escalation reasons mentioned in the stack, right?
Yeah, exactly.
It's not enough for the AI to just halt its process and ping a human with a generic message like, I need clarification.
Yeah.
It has to be engineered to state exactly why it paused. It should be outputting something like, I found 2 possible interpretations of this financial data, and choosing the wrong interpretation changes the final external action. It needs to articulate the stakes of its own doubt.
And by forcing the system to articulate the stakes, you map its internal doubt to a tangible, real-world outcome. It stops being this abstract statistical probability and becomes an actual workflow decision.
That flows naturally into the second mechanism the sources focus on, which involves how the system handles retries. They call it retry metadata.
Retry metadata.
Yeah, there is a strong argument here that having an agent retry a failed task without maintaining memory of the previous attempt is basically just superstition.
It is entirely superstitious. Think about the mechanics here. If a system fails a task, outputs trying again, but it doesn't log what variables change.
Right, like did it switch to a different language model?
Exactly. Did it use a different search tool? Did it reduce the scope of its query? If it doesn't track that, then it isn't actually learning or adapting. It is just rolling the cryptographic dice again, hoping for a different output.
The visual the source uses to describe that behavior is just brilliant.
Or the Roomba.
Yes. It says an agent failing the exact same way 3 times and getting more confident each time isn't demonstrating persistence. It's behaving like a Roomba attacking a chair leg with a mission statement.
It's a hilarious image, but it highlights a really critical danger in agent deployment. Autonomous systems often fail in ways that masquerade as progress.
What do you mean by masquerade as progress?
Well, they generate a lot of token output, they spin up compute, they look incredibly busy.
Ah, so they look like they're working hard.
Right. But if the retry metadata isn't strictly tracked and attached to the loop, the human operator has no evidence to inspect. You can't tell if the system is intelligently adapting its approach or just stubbornly repeating a broken path.
Which brings us to the ultimate unglamorous safety net stop conditions. This is the third mechanism, and it dictates the exact rules for when an automated system must completely halt all operations.
The hard break.
The hard break. And the crucial detail here is that stop conditions are entirely based on a concept called the blast radius.
The blast radius. That is the synthesis of uncertainty and consequence right there. It acknowledges that not all errors carry the same weight.
Right. The source gives a very practical breakdown of how blast radius changes the rulebook.
Yeah.
If an agent has low confidence while drafting a private internal document, that's fine. The system should label the paragraph as uncertain and keep moving.
Because the blast radius is contained entirely within a draft folder. No harm done.
Exactly. But if that same agent has low confidence on a post scheduled for a public brand account,
The stop condition must be an absolute cold halt. Do not pass go.
or take research, for example, missing a citation for a private brainstorm, mark it as a hypothesis and proceed. But missing a verified source for a factual claim in a public podcast script, stop the execution or immediately downgrade the language of the claim to reflect the missing evidence. Intelligence in these systems isn't just about choosing the mathematically correct answer from a latent space. True operational intelligence is choosing the next safe move.
The next safe move. I like that.
Yeah. The phrase, "I might be wrong," is never sufficient on its own. The operator always has to engineer the system to ask wrong about what, in what context, and with what blast radius.
And, to enforce these stop conditions
Yeah.
and to verify that the agent isn't just hallucinating its retry metadata, operators require hard evidence. You cannot rely on an LLM's text output to prove it did the work.
Here's where it gets really interesting, because to solve that verification problem, the sources pivot to a pretty surprising architectural lesson from the crypto world.
Oh, yeah, this was a twist.
Specifically, they point to Bitcoin and the Nostr protocol.
It is a fascinating pivot for the AI builder community. They are currently rediscovering a truth that protocol engineers have understood for over a decade. Claims are cheap, but receipts are better.
When I first read the mention of Nostr, I have to admit I had some serious pushback.
I don't blame you.
Are the sources seriously suggesting that every AI agent needs to be posting its private internal diary, like every thought and action, to a public social media relay? Because I feel like the absolute last thing the internet needs is millions of AI agents live tweeting their internal monologues.
No. Thankfully, the author explicitly pleads against that. They write, quote, "Please do not build that. The world has enough automated posting."
Okay, good. That's a relief.
Right. The lesson isn't about using the public network itself. It's about adopting the underlying primitives. Nostr's basic mental model relies on signed events and portable identity.
Let's break down what that actually means mechanically in the context of an AI agent.
Okay, think about it this way. LLMs are fundamentally text generators. If an AI generates the string, "I successfully searched the database," that is merely a claim.
It's just words.
It is just language, more trust theater. But if the AI architecture requires the system to produce a signed event, a cryptographic receipt, generated not by the LLM, but by the database itself, you have something real.
Ah, I see.
That receipt shows exactly who asked for the action, what specific tool result shaped the decision, and the exact timestamp. It is inspectable mathematical evidence. A signed intent proves the request was authorized. A receipt proves what actually happened.
It's basically the difference between an assistant verbally telling you they deposited a check versus them handing you the physical deposit slip from the bank.
Perfect analogy, yes.
And the sources bring up the Lightning Network, too, which makes perfect sense when you start thinking about AI agents touching actual money or settling invoices.
Yeah, no.
If a piece of software is going to autonomously route financial value, relying on a log that says the agent seemed confident is an absolutely unacceptable governance model.
Completely unacceptable. You need structural limits, cryptographic signatures, and pre-commit checks. You need logs that survive the chat window closing and cannot be altered by the LLM itself. If an agent hits an uncertainty loop regarding a payment route, the stop condition needs to be enforced by cryptographic reality, not just the model's language processing. As the documents state, receipts beat claims. Receipts over vibes.
Receipts over vibes. I think that might be the defining mantra for the next generation of AI development.
It really should be.
So to bring all of this together and kind of distill the pragmatic advice from this deep dive, if you take one thing away from these May 12 documents, let it be this. Do not measure your AI system's safety by how often it uses the word uncertain.
No, don't do that.
Measure what that uncertainty actually changes in the workflow. Does the doubt trigger a smaller, safer action? Does it automatically call a secondary verification tool? Does it escalate the problem with a highly specific reason?
And if we connect this to the bigger picture, the true mark of next-generation AI won't just be larger models with trillions of parameters.
Right, it's not just about size.
Exactly. It will be verifiable operational trust. The industry is moving from asking, what can these agents do, to how do we mathematically know what they did and when should they stop? Systems that know exactly when to halt, and leave an immutable trail of evidence for why they made that decision are the only systems that will actually survive real-world production environments.
Which leads to a direct challenge for you listening right now. If you are building AI tools, or even if you're just using them to automate daily tasks at your job, audit one of your workflows today.
Just one. Start small.
Find one specific place where the AI expresses doubt or provides a caveat. If the system's external behavior doesn't fundamentally change when that doubt occurs, you need to add a consequence. You need to make the uncertainty do some actual mechanical work, force a citation, trigger a retry with memory, or implement a hard stop.
Loops over language.
Exactly, loops over language. And I want to leave you with a final, slightly provocative thought to mull over. It builds on a passing but crucial mention in the sources about handoffs.
Oh, the handoffs?
Yeah, the documents note that handoffs are where fake certainty goes to hide. In a mathematically clean handoff, an agent should effectively say, here is what I know, here is the specific tool that failed, and here's the data I couldn't verify.
It should be a completely transparent transfer of uncertainty.
But think about where our future workflows are heading. We are rapidly moving toward ecosystems that rely on swarms of different agents handing tasks off to one another.
We are.
So what happens when a highly reliable, mathematically sound, loop-driven agent receives a beautifully polished, falsely confident summary from a legacy humility theater agent?
That is a terrifying thought.
Right. Will our hyper-safe, receipt-driven agents be completely compromised not by malicious human hackers, but by the polite, blazer-wearing AI colleagues they are forced to collaborate with?
Wow.
It's a fascinating vulnerability to consider as these autonomous systems start talking directly to each other. Just something to think about the next time your AI politely tells you it might be wrong.